Removing duplicates from a list of lists. I have a list of lists in Python. And I want to remove duplicate elements from it. Was if it a normal list not of lists, I could use set. But unfortunate that list is not hashable and can't make set of lists. Only of tuples. So I can turn all lists to tuples, then use set and back to lists. But this isn't fast. How can this done in the most efficient way? The result of above list should be I don't care about preserve order. Note, this question is similar but not quite what I need. Searched so but didn't find exact duplicate. Benchmarking. Loop-in, quadratic method, fastest of all for short lists. For long lists it's faster than everyone except groupie method. Does this make sense? For short list, the one in the code, 100,000 iterations. For longer list, the one in the code duplicated 5 times.
itertools often offers the fastest and most powerful solutions to this kind of problems, and is well worth getting intimately familiar with. Edit. As I mentioned in a comment, normal optimization efforts are focused on large inputs, the big O approach, because it's so much easier that it offers good returns on efforts. But sometimes, essentially for tragically crucial bottlenecks in deep inner loops of code that's pushing the boundaries of performance limits, one may need to go into much more detail, providing probability distributions, deciding which performance measures to optimize. Maybe the upper bound or the 90th centile is more important than an average or median, depending on one's apps, performing possibly heuristic checks at the start to pick different algorithms depending on input data characteristics, and so forth. Careful measurements of point performance, code A versus code B for a specific input, are a part of this extremely costly process, and standard library module time might help here. However, it's easier to use it at a shell prompt. For example, here's a short module to showcase the general approach for this problem. Save it as nagic.py. Note the sanity check, performed when you just do python nagic.py, and the basic hoisting technique, make constant global names local to each function for speed, to put things on equal footing. Now we can run checks on the tiny example list. confirming that the quadratic approach has small enough constants to make it attractive for tiny lists with few duplicated values. With a short list without duplicates. The quadratic approach isn't bad, but the sort and group B ones are better. Etc., etc. If, as the obsession with performance suggests, this operation is at a core inner loop of your pushing the boundaries application, it's worth trying the same set of tests on other representative input samples, possibly detecting some simple measure that could heuristically let you pick one or the other approach, but the measure must be fast, of course. It's also well worth considering keeping a different representation for K. Why does it have to be a list of lists rather than a set of tuples in the first place? If the duplicate removal task is frequent, and profiling shows it to be the program's performance bottleneck, keeping a set of tuples all the time and getting a list of lists from it only if and where needed, might be faster overall, for example.
Doing it manually, creating a new K list and adding entries not found so far. Simple to comprehend, and you preserve the order of the first occurrence of each element should that be useful, but I guess it's quadratic in complexity as you're searching the whole of new_K for each element.
I don't know if it's necessarily faster, but you don't have to use two tuples and sets.
List of tuple and can be used to remove duplicates.